again, the optional part with the related stage code. I think you probably have noticed by now in my notes, pretty much structured the same way for each section. At the end of this, you'll see something about related stage code. I do want to point out this is optional. We're not going to test you on it. However, if you're thinking about moving forward, you probably should learn how to use a computer algebra system. There's many computer algebra systems out there. The Advantage of Sage, it's free, it's available. Again, in the past, I recommended you just click on this link over here. It'll bring you to a website. On that website, you can use the CoCalc Instant Sage worksheet. I'm not going to do that though. What I'm going to use is my terminal. All right. Now, the reason for that is it's just, I'd rather have something running on my computer than depending on a web-based application. But that's up to you. You don't have to install the software. Again, you can go back to this link over here and use the online version of Sage. So what I want to do is I just want to go back over the notes. And I think that in this section here, which is section 3, you'll notice in the notes, there's, like code down. So like, for example, problem number 9 says use your calculator. I'm not telling you what calculator to use, by the way, but you should know how to use a calculator, including Sage. So this, not that we'll do this problem later, but the bottom line is, if you look at this one over here, and I want to type that in, I would type, it looks like an arithmetic problem to me, right? 0.8, 5, 6, 7, star 60. And what does it do? It does the multiplication for me. A lot of people look at that number and say, why are there so many zeros in it? It looks like it's padding it. And typically what it's doing is it's just at its level of precision. And you might be surprised by this, but Sage can have an arbitrary level of precision. All right, now someone says, I'm really tired of just copying all the time. You can do a copy paste if you like. And I'll show you that now. And we'll talk about what this line of code does. The first line I gave you was just simple multiplication. All right. So someone says, what did that just do? I want to tell you what it did. It took the fractional part of the number we just computed, which is 0.402, and multiplied it by 60. That's what that fractional command does. And what do you get? 24.12. This has something to do with this problem over here, number 9. All right. As you go through the notes, you're going to see these little embedded tidbits of code that you should start thinking about. Maybe I should see what that code does by typing it into Sage. Let's keep scrolling through this. Here's another one over here. I'm going to type it in. Let me type in the clear first. You notice this is a transparent terminal. I can see behind it. Reset. And again, you might get tired, so I'll just copy this in. And again, I want to claim this has something to do with problem number 14. You may not know that until you try problem 14. I'll put R down. I'm doing a copy paste, by the way. Omega, V over R, copy paste. All right, here's something that looks really strange to me. And I'll explain it to you. So it's taking omega, which is a computation, which is V divided by R, multiplying it by 10, and then you see this dot notation. And I'll tell you what the dot notation. They want a numerical approximation to that. Right, a numerical approximation. If I didn't put the dot there, right, what do I get? 880. Now someone says, what's the difference? Do you notice the difference is a decimal point in one of them? A lot of times we need to force a computer to put a decimal point down. All right, let's show you this one over here. And again, it has something to do with that dot notation. It's making a computation. The dot n with parentheses on is approximated. Now, if I didn't put that approximate there, watch what I get. All right. So someone says, what is that? It's not the approximate answer. It's the exact answer. But a lot of times you want an approximate answer. All right, let's keep scrolling through this. Again, this is an introduction. We're just trying to get your feet wet using code. All right, this one over here, yeah, it looks really kind of the same thing. I'll do the reset. You might learn by typing, but I don't know. I guess I'll copy this in, right? I think some of you guys might be taking computer science where you're looking for code online and doing copy paste. Not a very good idea. All right, I'm going to do this, and I'm also just going to show you what S looks like. That was S approximate, S exact. There's a big difference between the two, by the way. It's much easier to read the approximate answer, 4,477 point something. The approximate answer, that's not easy to read. 38,480 divided by 27 divided by pi. All right, I'm sorry, multiplied by pi. Let's keep going. See it in the homework as well. All right, the reason I put in the homework, we're hoping you're willing to go through the code to learn and to move forward. We're looking forward to you guys moving forward in your careers. And your careers largely depend on the level of education you're going to receive. So, last but not least, if you look at this thing in the very end of this section, you'll see some, related stage code. Thank you.